Hello students, this is Bappaditya Chakravarti and you are watching the YouTube channel Chemistry for Neet, and today we are going to discuss the electrophilic substitution reaction. Now what is electrophile? Electrophile means which are seeking of electrons. Electrons means a negative charge. So an electrophile must carry a positive charge, or an electrophile is an electron deficient species which will attack to an electrophilic center. Now what is an electrophilic center? Electrophilic center means where electron density is more, like benzene. You know the structure of benzene. Benzene is cyclic and planar structure where 6 carbon atoms form a hexagon at the same plane. Each carbon is sp2 hybridized. That means each carbon forms 3 planar bonds here, here and here. So here hydrogen atom is present. In case of this carbon, all have trigonal planar shape. This is benzene, but here each carbon has made 3 sigma bonds, so each carbon contains a pi bond, and each pi bond of one carbon is parallel to the other. Okay, so they can make a head-on overlapping with each other to form a pi bond. The lateral overlapping can be occur here. If your lateral bonding occurs, then these two pi orbitals can make a lateral overlapping. So here alternative pi bonds are formed, alternative double bonds are formed. The simpler form of benzene is this. Alternative double bond is present. So you know that the main 6 carbon atoms lie on the same plane and the pi electrons are above and below the plane. So these pi orbitals, this pi bond are not so strong, so they cannot hold each other. So these pi electrons are mobile. Mobile means if some electrophilic center is there, if some positive charge is there, these pi electrons can easily be moved towards that positive center. That is how electrophilic substitution of benzene occurs. Okay, now in benzene, if we give an electrophile, say electrophile means which is carrying a positive charge, say NO2 plus. If we add NO2 plus in benzene, one of the pi bond will attack to this positive center, as these pi electrons, I have said that the pi electrons are labile. Labile means mobile, so it can move towards the positive center. If the bonds breaks from this carbon, so this carbon here, a carbocation will be formed. This carbon will contain a positive charge. So what will happen? These two bonds remain intact and the bond is broken from this carbon, so there will be a positive charge on this carbon, and here a hydrogen was already there. If the substituent NO2 comes, that electrophile comes, then one has to go above the plane and the other has to go below the plane. So the substituent electrophile NO2 plus will present above the plane and hydrogen will present below the plane. Then what happens? This bond breaks and here double bonds, making a double bond, and hydrogen eliminates. Hydrogen eliminates as H plus ion by giving up its bond pair electrons, and then double bonds again come here. This process, why this step happens, because here only 4 pi electrons are present. 2 pi bonds means 4 pi electrons are present. The compound is cyclic, and here the aromaticity regains. Aromaticity means the cyclic compound, planar cyclic compound having 4n plus 2, that means either 6 or 10 number of electrons. Here you can see that 3 pi bonds are there, so 3 to the 6 pi electrons are present. The compound is cyclic and also planar because each carbon is sp2 hybridized. That's why benzene is aromatic, and aromatic compounds are more stable than non-aromatic compounds. So to regain the aromaticity, H plus has to be removed. Okay, so this is how here hydrogen atom was present, and now in place of hydrogen there is NO2. So NO2 has replaced hydrogen, NO2 plus has replaced H plus. That is why the reaction is called electrophilic substitution reaction, where an electrophile substitutes one of hydrogen or benzene. So this is an example. This is actually a nitration reaction. So this is an example of electrophilic substitution reaction of benzene. Now how this ion formed, this NO2 plus ion, is called a nitronium ion. Nitronium ion is formed when you add a mixture of concentrated sulfuric acid, and nitric acid at a temperature 50 to 60 degrees centigrade. This is nitration reaction. Nitrobenzene is formed, benzene, and here NO2. So nitrobenzene is formed. Okay, the mechanism for substitution is here, but how the nitronium ion, NO2 plus ion, is formed? HNO3, we can write HNO3 as HO bond NO2, right? HNO3. You can write HNO3 as OHO bond NO2 if sulfuric acid is given. Sulfuric acid being a strong acid, it can donate H plus ion, or it can get ionized to form H plus ions. So here H plus ion comes from H2SO4. Now that H plus ion, by this H plus ion, the oxygen of this OH group get protonated. Oxygen has a lone pair electron, so and H plus has a vacant valence orbital, so oxygen can make a coordinate bond with H plus ion. So here oxygen attacks H plus ion by its lone pair electron, and a coordinate bond is formed between this oxygen and this H plus, making H2O, then bond NO2. Now since oxygen has given up its lone pair electrons, oxygen will carry a positive charge here. Now this bond breaks to form neutral H2O molecule, and since the bond pair is given away, NO2 plus ion is formed. This ion is called nitronium ion. This is the generated electrophile in the nitration reaction of benzene. Okay, so the nitration reaction of benzene is an example of electrophilic substitution reaction, where the electrophile is NO2 plus, and how this electrophile is generated if we take a mixture of concentrated nitric acid and sulfuric acid, then the oxygen of nitric acid will get protonated by the H plus ion, which comes from sulfuric acid by the dissociation or ionization of sulfuric acid, and by this NO2 plus ion is formed, which is the generated electrophile. Now NO2 plus attacks the benzene ring. Here the reaction mechanism is already given here. I can write it again for you. Now this NO2 plus comes, pi bonds attacks the NO2 to form this ion. Here plus charge is formed as the bond is broken from this carbon. NO2 present above the plane and hydrogen present below the plane. Now here a new thing may occur, that is, here a resonance can occur where this pi bond shifted towards this carbon to make a double bond. So since the pi bond is broken from this carbon, the positive charge is now here, so it can be a resonating structure of this cation. Then again what can happen, this pi bond can make a double bond with this carbon, so another resonating structure is formed here. Now the positive charge will shift to this carbon, NO2, hydrogen, then hydrogen may give up its bond pair electrons to this carbon to neutralize the carbocation, to neutralize this positive charge, and as a result of that a double bond is formed, and now NO2 is present. instead of hydrogen. So this is how NO2 replaces the hydrogen atom and the benzene regain its aromaticity, and so the positive charge lies between this carbon to that. So we can write this as the positive charge is dispersed over these carbon atoms, and that is why this is called the sigma complex. This is the sigma complex. So that was the nitration reaction of benzene, an electrophilic substitution reaction. Now here we will see the another electrophilic substitution reaction of benzene, which is very popular, and it is Friedel-Crafts reaction.